I've been in the market for a Variac and an isolation transformer. And been doing some research, and I came across this model number SC-10T. And it just so happens that it's an isolated Variac. 10 amps. And so I ordered one. Well, it came in, but unfortunately wasn't packed very well. And it was broken. The brushes on the wiper mechanism were broken. And as a result, it wouldn't work. So, instead of just returning it, bought it on eBay. Instead of just returning it, I got a hold of the local distributor in America, PHC Enterprises. And to my surprise, they've got one of the best customer service departments I've ever ran across. Well, just like everything, UPS shows up late in the afternoon, and I didn't get this until after dinner, and opened the box up and came out here around 8 o'clock, and lo and behold, it was broken. So started taking it apart, looking at it, and found what the problem was. And that evening, around 9:30, 10 o'clock Central Time, I emailed them, PHC Enterprises. About 15 minutes later, I got a response back and told them what the problem was, and they immediately said they were shipping me a brand new set of brushes, and they arrived today. Well, in the meantime, I wanted to see if it really worked or not, so I took the old brushes and rigged up some wipers, and using some brushes from an old tool that I wasn't using anymore, and I got it working, and it worked really well. But I'm going to take the time to go ahead and replace the brushes with the ones they sent me, and I'm going to post a video of me doing this, taking it apart. And while we're into it, I'm going to look at it and show you that it is an isolated transformer, and it is very good quality. Okay, we got it apart. Well, in doing so, we need to make sure, I learned this the hard way, first time, that we need to mark the shaft position with the wiper. So, give me a better. Okay. So we can line it back up for 0. It's a little easier. Okay, so I'll give you a little closer look at where the wipers were. Yeah, when this arrived, the wipers were completely broken, sitting in the bottom of the can. And I took them apart and shaved some old brushes from an old tool, and made those, and I'll keep them just in case I need some brushes in the future. But as you can see clearly, the factory brushes are much longer, so that'll give me a little more clearance up here at the top, and it'll raise that up and give this brush wire a little bit more clearance. So like I said, one of the things we need to be wary of is the position of the shaft compared to the brushes all the way down. So I'm going to go ahead and mark that here too. Line up marks, so we know where to line it up when we go back with it. So I'm going to take that. This right here keeps the tool down. The brush is pushed against Variac. So when I got it, it was loose like this. The brushes were broken. Now we're to a part where we can take the old brushes out, and you can see the difference, clearly see the difference between the two brushes. Okay, brushes have been reinstalled. Now we're going to hold up on the bottom. As you can see, I'll turn it over so you can see how loose this is. It's really loose. So we're going to get it all the way pushed up flush. Line the rings and these washers up. In the slot, push down, and as you can see, way more clearance. I can get better than that. Line it back up with my marks. Hold down on it. pretty tight. Okay, finish tightening it up. Alright, as you can see, I've lined the shaft back up with my marks. Make sure all the marks are lined up. That way when I put my knob back on, it'll line up with it'll line back up with our scale. So I'm looking at it. Rotates really smoothly, and I've got a lot more clearance between the wire and the brush holder. So I hope I've got enough of it in the picture. So we're just going to talk about this isolation transformer and how it's wired up. So as you can see, we have your incoming power comes in hot and neutral. Neutral goes to this side of the primary. Hot goes through the switch, through the fuse, and to the other side of the primary, which is the brown wire, on this toroidal transformer. And here's your secondary side wound around it. Blue wire goes to the neutral of the receptacle on the isolated side, and your red wire hooks to your wiper, your varied voltage. And it's completely isolated, and I'm going to show you that it is. So we have your primary coil, neutral side, hot side, and then we have our secondary side, which is your neutral and your hot. And that voltage is varied according to the wiper. But as you can tell, I'm on the neutral side of the secondary, the neutral of the primary, and nothing. Go to the primary hot to neutral, nothing. Hot, nothing. Nothing. So as you can see, it is completely isolated. Now I have removed the ground wire and taped it off from my receptacle on my isolated supply. I know there's debate on whether that should be done or not, but for my projects I'm working on, I decided to remove the ground. So I emailed PCH Enterprises, and they sent me this document, spec sheet more or less, about the Variac, the SC-10T. And as you can see here, it clearly has a diagram that shows the isolation from the primary and secondary side. Some of the specs associated with it. Surprised it was actually a Excel spreadsheet, but it's fairly accurate to what they have. Even shows what size box. Not much else. So we've gone over the basics of the limited repair of this isolation / Variac transformer, and just want to point out that I did replace the the Chinese version of an American receptacle with a real American, I guess American, maybe American Chinese built-in China receptacle. But the issue I was having with this one was the contacts were really loose. As you can kind of see here, it just, I mean, it just slips right in, right out. Doesn't have any holding power at all. So I went ahead and swapped it out with a new one. I plan on replacing this analog voltage scale with a digital scale, using an Arduino and some other parts, but that'll be another video. Let's go ahead and put this sucker back together and plug her in and try her out. Okay, I've got it back together again, and I've got it plugged in, and I'm going to go ahead and test it. So, stick my meter in, got it all the way down to 0 on the scale, turn it on, it looks like I got 0.7 volts AC, and crank it up slowly, and that looks like on the 5 scale, which is pretty close. 5, jumps up to 10, it's like 11, 15, so the scale below end looks pretty accurate. Let's jump it on up to 50 volts, see what we get. 50 says 54, 55, there's 90 volts, says 102, drop it down to 90, see where that reads on the scale. 90 actual volts. It's reading about 80. Let's jump it up to, see where to go full scale. 140 volts full scale, which this says 130, so that would should tell us why we're off all the way through, which I don't mind that. Like I said, I'm going to be replacing the analog scale with a digital scale, so there won't be a need for me to really look at the scale on top. Just look at the voltage. Okay, what I've got set up here is to prove the isolation portion of this Variac. So what you see here is I've got two 120 volt sources. The red one is coming from an isolated Variac. I've got the Variac set to the maximum, which should be somewhere around 140 volts. The blue taped lead is coming from my house power, unisolated. So you can see this, I've got this meter set up to read amperage, and I've got it set up to read microamps. This one's set up to read volts AC. So we'll look at the house power coming in, and we've got 116 volts. and we'll look at the Variac, and we've got 143 volts. So, to prove the isolation, I've hooked up a 1 ohm resistor, and I'm going to put it in series between the two hots. This Variac does show induced voltage, and I'll show you this right now. So between the two hots, the hot on the house and the hot on the Variac, we're showing 112 volts AC, but that's induced voltage. The way I can prove that is I'm going to read amperage through this meter, and you can see that it's reading 69 microamps, and the voltage goes down to 7 millivolts. Remove it, and it jumps back up. Induced voltage, totally harmless. We can do the same thing with the neutral side. We will hook it up there. We can read voltage neutral to neutral, 120 volts. Move the resistor over, and as soon as I hook it up, again, 73 microamps and 7 microvolts. Oh, always happens that way. There we go, 73 microamps and 7.4 millivolts. And it jumps back up. Okay, so to prove ground isolation, what I've got here is I've got a ground wire that's hooked to the 120 volt ground of my house. And again, we've got the isolation voltage coming in here, 140 volts. Shows 140 volts. And we've got my amp meter set it for micro amps. And between the neutral and the ground of my isolation transformer, it shows 121 volts AC. That's induced voltage, and the way I can prove this, I've got a 1 ohm resistor. Complete the circuit. I get 74 microamps, and it drops down to 8.3 millivolts. Release it, and the induced voltage is back on, completely harmless. And to show you on the hot side of the isolation transformer, I've got 6 volts or so to ground, and that drops down to millivolts with 0.2 microamps when I complete the circuit, shorting it out. Completely isolated. So that's it for the simple repair and just basic test of the SC-10T isolated transformer Variac combination. Very impressed.